Thank you for joining XROM, which is India's first AR/VR focused podcast. And today I'm delighted and honored to have with me Misha Sra. So, Misha, welcome to the show. It'll be really cool if you could start with a brief introduction.
Absolutely. Well, thank you, and really glad to be here. Well, as you mentioned, my name is Misha Sra, and I am an assistant professor at the University of California, Santa Barbara, where I direct the Human AI Integration Lab. And what we do is we build new kinds of technologies, both we engineer, design, do user studies, and all of those things, looking at how humans and machines could work collaboratively, how we could actually use AI-based systems to help improve our own human abilities and things like that. And of course, the technologies that we use to visualize everything is augmented and virtual reality headsets. That's where the connection to that is.
Lovely. So, I want to get into your lab, which is the Human AI Integration Lab. But before I get into that, I want to understand what was it that nudged you into getting into virtual reality?
It's an interesting question because I'm a huge fan of science fiction, and some form of virtual reality is a big part of science fiction. I mean, just the word metaverse comes from Neil Stephenson's book, 1992 book Snow Crash. So when the first Kickstarter project happened in, I think, 2012, when Parma Lucky was building the first Oculus DK1 headset, someone I knew had funded that Kickstarter, so they received that headset. And I was like, oh, let me take a look at it and see what it does or what it means or how we can figure out how can we write code for it and build something. And then the first time I built it and put it on, I was like, I mean, at the time, screen door effect was big, graphics, resolution was bad, graphics weren't that great. It was a demo called Tuscany Villa or something, very first demo. And yet, when you put the headset on, and that was the first time I'd ever done it, it just felt like I was there, despite all the limitations. And I think that was so different from, playing a 3D video game on screen or something else. You're there, it's first person, but it's still different from being there in VR. And that sort of got me down the road of doing VR.
Even right now, possibly these rudimentary experiences such as the Richie's plank walk, when you kind of get onto it, you're in a mall and you're not on top of a building. There's a plank sticking out, but when you walk on it, it kind of tricks your motor cortex into believing that that basic animation is real. So there's something very funky going on. Would you be able to elaborate on that? Even today, if it's doing something like this, what would virtual reality or metaverse could possibly do to a
Mhm.
human being in experiences possibly maybe 15, 20, 30 years down the line?
So I think it is an interesting experience you build up the walk on the plank, and there's many versions recreated. It's originally a very, very old research project, right? That was plank around a small room. And yes, time and again, it's been shown that people are afraid. And you know that there's nothing there. You know you're in a room or wherever you're standing, and yet your mind responds, your body responds with the same symptoms of fear of heights that you would in real life, right? Which is super interesting. And this very fundamental response, this is called place illusion, at least in literature. And there's many definitions of sense of presence, right? And the one that I mostly subscribe to is by Professor Mel Slater, and he describes two kinds of predominant illusions in VR. One being place illusion, which is essentially a sense of presence. You know this is not real, right? You know that you're in your living room or in your office, wherever you are, but yet you're responding as if it's real, right? So that's your sense of being somewhere. And then the other thing is plausibility illusion, which is you know that whatever is around you in the virtual world that's happening is not real, but you engage with it in ways as if it's real. Right. So everything seems plausible. And both these illusions, during a VR experience can break. Because if you're walking around in your room and suddenly your the barrier, the guardian comes up and tells you, oh, you're out of your walking space or something, and you're about to hit the couch. And suddenly you're sort of thrown out of that place illusion for a few seconds, but then you step back, you're back in whichever world you were in, and you're back in your virtual place. It's a little bit challenging with the plausibility illusion, of course. Once that breaks, then your sense of your suspension of disbelief just goes away. And, that thing you don't really get back. So, speaking of what kinds of things we can do down the road with it, like right now, if you think about it, VR is fairly limited, right? We only have the visual sense, and then spatial sound is more again becoming popular. And as you just mentioned, sound is a huge factor in creating an experience. So we think about all the senses that we have in the real world that go on to create an experience, right? We got smell and temperature and textures and all sorts of things we can feel, which are missing in VR. So we try to imagine all of these added to VR. We could potentially, as an extreme case, think of recreating the Matrix. Now, the question is, do we want to recreate the Matrix? Or do we not even recreate? I should say, do we want to create the Matrix, right? Is that what we're going for? Is that sort of the epitome of VR? I personally think no. I think that we should be using VR to create experiences that are difficult to have in real life. We should sort of take advantage of the technology to give experiences such as, for example, not everybody is able to go scuba diving, whatever their reasons are. Could be health conditions, could be cost, could be travel, like all sorts of things, right? Age, many limiting factors. But going underwater in an ocean could be a spectacular experience for so many people. And we could build a VR experience, which we actually built several years ago, to give them that kind of experience, which wasn't possible for many people in real life. Maybe you're afraid of water. I mean, it could be anything, right? Similarly, there could be, you could fly. There are many experiences like that. You could experience being in the body of a different type of animal. You could be a dinosaur. You could be a lizard. You could be an alien. All these experiences that you really can't have in real life. Right. So from an experience perspective, that's what I personally think, that those are the kinds of things we want to focus on. You can manipulate physics in VR. You can't do that in real life. You can't turn off gravity today. I mean, you could go in a vomit comet and have some simulated zero gravity, but generally when you're on Earth, you can't just turn it off. And right, so down the road, right, the potential for the tech to recreate reality exists. So we continue down the road of improving visuals, improving graphics, sound, start adding more sensory modalities to it. Haptics comes to a point where it almost feels like we have a second virtual skin. We can feel everything. But the bigger question, I think, is do we want to? Do we want to create and live in a matrix?
Right. So this obviously, it's a question where it goes down in the rabbit hole. And as humans, I think, obviously, we need to ask a question: where do we actually want to go? But then there are those only select few people who would ask those questions, because with the democratization of technology, there'll always be some kid sitting somewhere in the basement tinkering around. And you rightfully pointed out, I mean, technologies which can kind of mimic all of our five senses, which is pretty much now becoming realistic. Could take possibly 40-50 years more for us to be possibly emulating our entire brain and our cognitive functions structurally and functionally, to possibly maybe create a simulation which is indistinguishable from reality. If we are going down that path, is it actually possible? B, what's your thought about the entire conversations around Nick Bostrom, Elon Musk, Donald Huffman, and many others who say that reality itself is a simulation, with Donald Hoffman saying that space-time, which was fundamental, is not fundamental anymore, and it's nothing but what are your thoughts around that?
Okay, so two questions you asked, right? Like, is realism to the point of us being in the matrix possible or not? I would say very, very challenging. And I say that because if we think about, we can simulate smell and we can simulate taste, we can electrically manipulate, receptors on the tongue and things like that. But the nervous system and the skin, which is a general purpose haptic sensory device, that I think is going to be super challenging to recreate, even let's say 40, 50 years. Because if you think about it, right, our skin allows us to pretty much feel so many different types of sensations, from temperature to lightness to texture, coolness, hardness, softness, force, and tactile sensations. Whereas so far, if you look at research in haptic design, every single sensation, you have to build a separate device for it. Right? There is no general purpose yet, not even close, not even the idea of a general purpose device. And to be able to recreate reality to that fidelity from a sensory perspective, we would need something like that. And I think we're long ways, unless, we can actually directly simulate the brain, or stimulate the brain, I should say. So something like, if you watch anime, and then there's a few shows out there like Sword Art Online, or where the device that you're wearing that's giving you this sense of being in another world is just directly plugged into your brain, right? So if everything is happening in the brain, then it's possible, because your brain already knows how to perceive all these senses, even without actually engaging these senses. You already know what touch feels like. So then it's possible, that pathway, versus the actual physical pathway of recreating the sense of fidelity, which I think is harder. Well, actually, both are pretty challenging, and both may be long ways off, if at all possible. And to think about your other question about Nick Bostrom and all these hypotheses about living in a simulation, other folks questioning what reality is. I mean, humans have questioned what is reality since the beginning of time, right? And we're still doing that, and we still don't have any answers. A lot of thought experiments on it, and a lot of, I guess, arguments back and forth trying to prove one way or the other, or at least try to demonstrate, if not conclusively prove. I don't know. I guess it's now a matter of which argument you want to sort of side with at this point, right? Like, do I believe whether we're living in the matrix or not, or is this a simulation? To me, it seems plausible, but kind of very, very low probability. I wouldn't say zero probability. Nothing ever is, but very, very low probability. Just thinking about the bizarre amount of computation needed to simulate something like this. The fidelity is just so high, right? And thinking about all the math and the modeling that would be needed to simulate every single microscopic thing that we have on the planet seems like tall order to me. But then again, maybe we're not the ones simulating. Maybe there's an alien species out there that's doing the simulation that are way beyond what we can even imagine at this point. And so to them, we're just ants. I mean, that's possible, right?
Right. I mean, that's again, it's like a very deep question. So, human machine interaction, over the years, it's evolved. Earlier interfaces were, keyboards. Then we moved on to computers, using all the 10 fingers to type. Now we've moved on to phones where we only use our thumb to type. And it's not just the thumb. I think, we interact with voice with, things like Siri and Alexa. And then now there is obviously AI, and AI is in the hype cycle because of the generative AI, where it's doing text to search, text to video, text to 3D, text to speech, and so on and so forth. So talk about the evolution of human machine interaction and some of your works at the Human AI Integration Lab.
Okay, I mean, so you kind of summarized the evolution of interfaces pretty well, right? I mean, if you look at computation, you go back maybe 70 years from now, like into the 50s, 60s. That's sort of when actually the whole area of human-computer interaction started in the early 60s, when you have folks like Doug Engelbart, who invented the mouse, and who sort of wrote an essay at the time called Augmenting Human Intellect, right? And so that's sort of one of those seminal writings that talk about how humans and machines could be integrated. So our work in my lab sort of goes back in terms of inspiration from prior writings in the space. There was JCR Licklider, who also wrote another write-up essay back maybe in 60, 61, something like that, called Man-Computer Symbiosis. And again, the same idea that machines at the time, or computers or technology, we want to expand it, is a tool that can be used to expand human ability. Right? And so in my lab, when I'm talking about human AI integration, I'm thinking about AI as a representation of this newer class of technologies that we're building. And how can that actually help improve our own capabilities to do things, whether it's physical capabilities, cognitive capabilities. I mean, currently at my lab, we're focusing on the physical abilities. And so that's right. So again, going back to the interfaces question, right? Like interfaces in the early days were punch cards. And before punch cards, you go even older and you just were plugging cables in and out of the wall and physically moving them around. And then the keyboard and mouse happened, then touch happened, and voice happened, and things like that, right? So in all this evolution, the mechanisms to interact with machines have become a lot more natural, closer to how humans engage with other humans or the real world, right? And at the same time, machines have also become smaller. You had room-sized machines, then you got computers and desktops, then you got laptops that made you mobile, you could communicate from anywhere, then you got computers in your pockets. With AR and VR, now you got machines practically attached to your skin. You got wearable devices and things that are constantly touching your face, right? So next step, and not even the next step, you already have technological devices that are implanted into the human body, right? We got some brain implants for medical purposes right now, or you got things like insulin pumps that people wear that are sort of partly embedded into their bodies or temporarily. So we can think about this as one frame of evolution where technologies are just coming into you, to you. And it's not that far-fetched to imagine what we were just talking a few minutes ago about potentially a brain implant being able to simulate reality for you, right? And there's lots of science fiction that talks about it. You got John Scalzi's Last Man's War and the brain pal in there and things like that, which, and then you look at older science fiction, which also talks about people and hardware, cyborgs, essentially, the idea of cyborgs in space, again, from the 60s, that man and machine or humans and machine, I mean, at the time they would say man, are coupled so tightly that they're sort of one entity. And in terms of a cyborg, most of this is physical changes to the body, right? With AI, we can think about what are other aspects of human abilities that we can augment. There's one very interesting article I read I'm blanking out on the name right now, but the example that they gave was, in terms of how tools are able to augment our abilities, is this very simple example of, if I ask you to multiply 2 times 2, easy to do in your head, right? I ask you 20 times 3, easy again. I ask you 384 times 426. You could do it. It'll take a few seconds. You think about it and you could sort of juggle numbers in your head. But I ask you to multiply 34782 times 46139. Now it becomes hard, right? But I give you a tool as simple as a paper and pencil, and it becomes easy. And I mean, if you think about it, it's just wood and pulp and lead, graphite, and that's a tool. And it's certainly augmented my ability to do something I couldn't do before. And, we think about along that evolution of tools doing that, and we arrive at AI, and we can then kind of come up with, okay, what AI has a potential to augment so many different things about what I can do. Right? And that's essentially what research in my labs looking at how can we take advantage of this new technology, but to build user-centered tools and applications, and whether it's hardware, software, some combination thereof. But the end goal is how can it actually help people?
Right. Yeah, I think you gave a very interesting example. You mentioned human-centered tools. I mean, those are the examples that you gave of the tools which is enabling us. And so, I mean, almost all the tools have like really enabled us. But the tools now are getting to the point where it could become an existential threat because the tool itself are becoming cognitive agents of sorts. You mentioned that in your lab you're leveraging or helping humans expand their physical or cognitive ability, largely physical. Would you want to elaborate on that? How do you expand the physical ability of a human? What are you doing that? And maybe address the downside also of an AI.
Sure. There's downside to everything. Right. Yeah, we want to have a more balanced perspective. We also want to have a very ethical approach to designing new technologies, which certainly have the potential to do harm, right? Depending on how they use. Okay, so for an example, let's say, and I'm talking about physical example, physical world example, right? That you want to build a tool that helps you learn how to do a new physical task, right? So maybe you're a mechanic, or maybe you're a medic, or you just someone who's working with physical things. You're not just someone sitting at a computer trying to do a search. So now we want to build a tool, and currently we're working on building or recently, I guess we paused for a bit. We were working on building an AI agent, and this agent is able to observe what you're doing, so through cameras, obviously. So you can imagine wearing an augmented reality headset, right? And it's got cameras on the outside. We can add new cameras, we can add other sensors to it. And this agent, which is sort of, you can imagine sort of like you can think of it as a person sitting in your headset. You can also imagine it as basically nothingness, just a voice in your head, right? It is looking at what you're doing, and then it's able to figure out what you're doing, right? It can say, oh, looks like you're doing XYZ. And then based on what it determines whether what you're doing is right or not, it can give you assistance, right? So it can give you instructions on do A, B, C. And if you make a mistake on step C, it'll say, oh, it looks like you're actually doing step D. You may want to do step C first, and then we'll go to D. So it's doing it all in real time, right? And then it's providing you feedback. Or feedback could come in the form of voice, of course. It could talk to you. It could show you feedback in AR on the screen. It could show you feedback on top of the physical thing. Like, you take a simple example of cooking, for example, and you're trying to learn to do something. And you can show animation that's embedded in 3D space on top of the physical object, so it looks like it's really there. And so now you're seeing everything from a first person perspective, and you're sort of learning by doing as a goal, right? So that's sort of an example of a physical task where AI could help. The only problem is that when you move things out of the digital screen, right? Like a lot of AI right now is sitting in the cloud somewhere. It helps you do a web search, or it helps you. It recommends movies to you on Netflix and whatnot and things like that. It's not real time back and forth. And it's also happening in a very controlled environment. Everything is digital, right? But once you get out in the physical world, now an agent needs to recognize physical objects. Lighting is questionable. It might be messy and it doesn't know. Is there enough data for it to learn from? Do we have the appropriate data sets? What type of feedback do people need? And do people even want feedback? People may want to figure things out themselves also. So the agent has to learn what is the right time to provide feedback, not just constantly be telling you, do this, do this, do this, because you're going to just turn it off, right? So, and if the AI makes too many mistakes, then how is a human going to trust the agent? Human's going to be like, oh, you don't know what I'm doing. I know what I'm doing. You're always making mistakes. I'm just going to turn you off or not pay attention to you. which is not the end goal, right? The end goal is sort of to be able to build a smart enough agent that is actually helpful, not annoying. And so real world challenges, much, much harder to deal with than digital world challenges. And that's sort of the space we're trying to work in. And then the flip side of the problem is, right, the agent is looking out at the world, what you're doing. But the user is also engaged with what they're doing with their task. And so what we're also trying to do simultaneously is do some user modeling, as in figure out what is the user's current emotional state? What is the user paying attention to? What is their cognitive state? Is there high cognitive load? Is there low cognitive load? Is this a good time to even interrupt them? Or are they in some kind of flow? And even if they're making a mistake, this is the wrong time to interrupt them. All of these things also need to be figured out to sort of have an optimum system. And it's interesting how challenging it suddenly becomes and how trivial it is for a human to do all these things, right? You can imagine a good friend of yours standing behind you, watching you do something in the kitchen or any other task for that matter. They know when to interrupt and help you. They can read your facial expressions. They can tell at which point you're frustrated, at which point you're open to help, at which point you just want to do it on your own. It's sort of trivial for humans, for the most part, to tell. But to try to model them and try to do it computationally, suddenly the challenges become tremendous. But in the end, if we're able to build something like this, you can imagine the value, right? Where people are able to learn things by doing them on their own in the real world versus, you go watch a video, pause it for 2 seconds, come back and try to do this, go back, do this again. Or, there are many, many things that require instructors. And not because you can't find instruction in a video, that's possible. It's because instructors provide meaningful feedback, which a video can't provide. Books can't provide feedback. Nothing really can provide feedback other than a real-time system or another human instructor. And so the other thing is, how do we build these virtual instructors that give a lot of people, millions of people out there who can't afford instructors but want to learn things the right way? How can we make learning basically physical things? We still live in a physical world. Most of our day is spent doing physical things. And then there's digital content on top of that, right? How can we make those learning experiences meaningful and valuable for people? So that's sort of the general space we're working in.
Lovely. Would you want to address the downside of?
Oh, right. I guess so. Anytime you're using an AI system, right? There's things you want to think about, because now you have a camera-based system that's looking at everything. So now you have privacy concerns immediately come up. If we're modeling a user's emotional state, now we also have a connection between what a user is doing versus what they're feeling, which is a little bit harder to decipher otherwise, right? And so privacy certainly becomes a big thing. And then depending on what kinds of tasks you're doing, what kinds of agents we're building, what kind of AI we're using, other things come into place related to ethics. It was interesting because I actually was teaching about ethics in class today, in my undergraduate class. And we're talking about all these challenges related to user interface design, where there's a whole side of design called dark patterns, right? Where interfaces are built in a way to nudge people or manipulate them to do something which they may not want to do, but the design is such that it's hard to tell or to figure out how to do the alternative that they actually want to do. And we don't want all these kinds of things. We ultimately want to build systems where humans are able to trust the agent, that the agent has their best interest at heart, which right now is hard, even with models, right? Models make mistakes. Models are random outputs. And that's hard to work with because humans generally expect if you press a button, it's always going to do this, It's not going to do a different thing every time you press the same button. And if it tries to do something different, then how do you know what it's going to do? How do you predict something? And without being able to know for sure what's going to happen, it's a little bit hard to think of something as reliable, right? So,
Right.
yeah. I mean,
Yeah,
there's, in general, it's a broad sweeping statement, but there's downsides in terms of privacy and challenges related to individuals and things like
right.
that, which companies will monetize one way or the other.
Exactly. Yeah. So there's so many pros, but obviously there are a few downsides, which obviously there'll be people trying to monetize that, because I think we live in a capitalistic world where uh, profit is kept right on top. So the
Yeah.
tech is
I
getting
guess
now.
the other one other thing generally comes to the forefront when you start talking about AI, as I was saying, let's say we're building AI instructors for certain tasks. Now, the first thing that people will talk about is what about humans? Are they going to be out of a job? But that's really not the point, right? Is there's just not enough human instructors to go around is the problem we're trying to solve. We're not trying to replace them, we're actually trying to augment them and then also help people who would never be able to afford an instructor to actually be able to get help.
Right. I
Um,
think you put it so nicely, because I guess the tech Luddites, or the ones who don't know about it, I think, push the conversation that, tech is bad. But I think there is nothing which is good or bad. It's humans, how we end up using it, and the direction we take it towards. It could be today, I think tech is loaded with the potential of creating abundance, and but yes, obviously it's got the downside. If it's got goes into the fringe element, it can go towards the downside. My last question to you, because we're running out of time. Education itself is getting upended, and we still, at least here in India, we're extremely structured, and we're pushing all students to the doctors and the engineers, while most of the jobs are being automated. I mean, and right from coding to creativity, which was supposed to be thought as something which the AI wouldn't get it, but even that. So quickly, if you could maybe advise students, what should they look at in terms of how they uh, understand, learn, and maybe the future of work.
hmm. I guess the first thing I'd like to say is that without human produced data, AI is nothing. Right? And so let's say we imagine a time when you talk about creativity where AI is able to create things. Right now, it's learned based on human created artifacts. And let's say all humans stopped creating anything. Right now, AI is sort of stuck in its own, I guess, kind of like a black hole. It's just basically churning similar things because it's coming out from the same set, right? So even its newness is sort of the sameness as before. And, that's where human creativity comes in because humans are able to put together things in very, very different ways that I don't think we have AI that can do that yet. So I feel like without human generated data, AI right now, the way it functions, the way it's designed, will not work. Right. So I don't, yeah. So in general, that's sort of my broad statement about that. Um, but in terms of future of work, I feel like, there's every new technology generates fears of things going away, but people pay less attention to new things that come into place also. Yes, some things go away, but many more new things come into place and many new types of jobs happen, right? Internet created so many types of jobs which nobody had even imagined at that time. Maybe people were just worried about the internet taking away certain types of jobs, and I'm not saying that doesn't happen. It does happen. Technology does change people's lives, um, but ultimately all this technology and new things that come also need management, figuring out how to run it, how to maintain it. Even if code is happening automatically, the hardware needs to be built to run code, and machines need to be kept running, and even code itself needs to be figured out, right? As we know, machines hallucinate, right? It's not everything that's created is actually appropriate or right or whatever, right? And so, in general, I feel like, learning, maybe the thing to learn is to learn to be able to handle and adapt to change, right? Learn how to learn and learn to adapt to change. And maybe those are the two big skills we need at the moment. And then we're ready to face whatever's coming. I
Lovely.
don't know.
Thank you, Misha. Really appreciate you taking time and being part of the podcast. What a profound note to end on. We need to learn and be ready to change, because being lifelong learner is going to help you into building a preferred future. So really appreciate you taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye bye. Thank you. Appreciate
Thank
this.
you very much for having me. It was great chatting with you.